Math 330, Applied Statistics. Just making a quick video here to talk to you a little bit about our sports analytics project. And this is, I think, part B. Part B. I'm going to share my screen with you and make a couple of comments. All right, very good. So what we see here, um, at part B and part B of part B. So this is the multiple regression part where you have to do the add-on in Excel. Yeah, and what we're trying to do is we're trying to make some sort of a prediction. In this case, I just use this runs plus RBI statistic. I just created it. You just add the two stats together. And what we're trying to do is create a linear function with the variables hits, doubles, triples, home runs, stolen bases, caught stealing, base on balls, grounded, double play, and hit by pitch. So literally it's going to be some number times hits plus some number times doubles plus some number times triples. What this tool is going to do is going to create a prediction for runs plus RBIs for every single player based on whatever their inputs are for these different things. And then it's just going to spit out these multipliers, these coefficients that will kind of tell us how much each hit or each double or whatever it is contributes to the total runs plus RBIs. So if you run through that process, I'll just go to my answer key right here. This would be right here under the weighted average tab. What happens is there's this output over here, this summary output. And if you click on the residuals box, so let's see here if I move me right here. Yeah, so if I go to data analysis and then we do the regression, input Y range, so that would be the column of runs plus RBIs, including the label. I got the labels box checked. And then input X range would be literally all of the columns that include the variables of interest with all that data. Output range is just pick a cell, and that's where it's going to start spitting all the information out. And then notice I clicked on this residual box right here. Don't worry about the plots and the line fits and all that. This residual thing is what you really want. So let's just cancel out of this because I've already done it. So here's your output and a few things that we care about. So this R square, a perfect R square, meaning that our formula works perfectly and accurately predicts exactly what the outcomes actually were, is 1. And so 0.97 is pretty good. So that's something to take note of. And then down here, the coefficients is really interesting. So what this is saying is 0.55 times the number of hits that a player got plus 0.33 times the number of doubles plus 0.25 times the number of triples. So these are the multipliers, and you can kind of see like relative to each other how valuable each thing is. You know, a hit is 0.55, whereas a home run is 2.07. So, you know, it's going to take essentially 4-ish hits to equate to the value of a home run. And a home run, you get a RBI and a run for, so it kind of makes sense that there's a 2 in front of this. So that's useful, those coefficients. And then over here, these p-values. The lower the p-value, the better able to predict each coefficient is on the variable. So these essentially, practically speaking, like this p-value is essentially 0, means that this hits variable is an important variable to us, and this 0.55 coefficient really helps us make a highly accurate, predictable runs plus RBIs. Like hits matters. It matters. But then over here, this 0.35 p-value, that's not very good. You want p-values under 5% in this case. So triples really is not a variable that's highly predictive in its ability to predict runs plus RBIs. Most likely is that most people don't hit triples, and even the ones that do don't hit very many triples, so it's pretty insignificant. You can see home runs is very significant. 3.9 times 10 to the minus 114. So the lower the p-value, the more important the variable is to, or as a contributor to the response variable, which is this Y variable, the runs plus RBIs. The other thing, since I clicked the residual box, it's going to give us these residuals. Now you could create these numbers. So like our formula predicts that player number 1 would have 203 runs plus RBIs, which is 18 off of what they actually had. And the absolute error is a residual is just an error, but the absolute value of the error is how far away that error is, and it doesn't include the negatives. So it's just the absolute value. Um, Now, what I did was I actually just copied these columns and I put them over here so that I could have them right next to the player that they're predicting. So you can see Marcus Semien predicted runs plus RBIs based on our formulas 203, but he actually got 222. So he did 18.6 better than predicted. Maybe that suggests that he had a little bit of luck involved, or that our formula just has some sort of like plus or minus ability to make a prediction. You can see that the next guy, he actually did a little bit worse than predicted based on these inputs. So he was a minus residual. But anyway, that's kind of an interesting thing. And then you can run the t-test on the runs plus RBIs against the predicted runs plus RBIs. And remember, with a t-test, it's a two sample match pairs t-test. If you run that test, if your p-value is low, like less than 5%, that suggests a significant difference between these values. And a high p-value, the highest p-value would be 1. So a high p-value suggests no difference. Or it more precisely um, indicates that there is not evidence to show a significant difference. So I guess in this case, if we're trying to make a prediction that's accurate, we're hoping to not see a difference. 230 and 233, that's really good. That means our predicting formula predicts pretty close to the actual number. And so p-values close to 0, less than 5%, suggest differences, significant differences between these two things. And p-values above 5% and higher up toward 1 show us very little evidence that there's a difference between the two. We're happy about that, right? If it will show that. The other thing I want to talk about is the z-score. And with these z-scores, what happened was somehow, I'm going to go back to this sheet. When you click on the sheet with all the blanks, there was some corrupted data beyond player 200. And so somehow what had happened was down here after player 200, there were some values that didn't match at all. It was like, these are percentages, and then there were just like whole numbers. So somehow someone got in here and changed some numbers. And so I took those all out. So if you want to do these again, it shouldn't take very long. Up through player 200, then we have the actual data for those players. Essentially, what we're doing is we're trying to figure out where each of these players is relative to everyone else by calculating a z-score, which is a z-score is the number of standard deviations above or below the mean that a particular value is. And so if you look at, so this player here hit 38 home runs. Your averages and standard deviations will be a little different than mine because I did not have corrupted data when I made this file. And so I had more players than 200, but I got an average of about 20 with a standard deviation of about 8. And so you can see 38 home runs. How many eights is that above 20.83? Well, it's 2.12. And so you can see that all you have to do to find a z-score is you just take the data point, in this case, 38 home runs minus the mean. So you just see how far away those two things are from each other. And then you divide by the standard deviation, and that will be the z-score. So this is a pretty straightforward calculation for each of these different categories. So you can see that this player he was 2.12 standard deviations above average in home runs. He was 3.2 standard deviations above. He's really good, obviously. 1.58. A negative z-score would be below average. And these are just number of standard deviations. Stolen bases, he's 4.87, almost 5 standard deviations above average. So average was 10 with a standard deviation of 9. He got 56, which is almost 5 standard deviations. So the deal here is you just take the z-scores and add them together, and you get the z-sum, and then you can sort according to the z-sum. Obviously, this formula, the way in which we're evaluating players, makes this player look like almost twice as valuable as the next highest player. And so it's not necessarily the most perfectly accurate way to evaluate, but it is a way. It's a way to create values associated with these players' abilities to accumulate statistics in the desired categories. So hopefully that helps. Sorry if there was any confusion. I'll stop the share and let me know if you have any questions. Have a great day.